Okay, here we go. We're on page 55 looking at exercise 5. So we've got a truss now between a roller and pin support, but this time we can see we've got vertical force and a horizontal force, but the horizontal force has been placed on the top of the truss. So that's what's a little bit different this time. Now we still deal with it like any other moment. It's force times distance, and the distance is perpendicular. So if we have a look at that, the perpendicular force of that 90 kilonewtons, if I draw a line perpendicular to it, and the distance from A is 1 meter. So that's the distance we'll be using. So we've got some reactions, boys, that we're trying to find. RL. We know at this pin joint that because this time we've got we've got a horizontal and vertical force, we're going to have an RY and an RX and an unknown, at this stage, unknown angle for the resultant RR. So straight into it, we're going to do a moment about point D, which will give us the reaction for RL. So looking at this 60 kilonewton force, it is spinning in an anti-clockwise direction around D, and spin that way. So that will be negative 60 times 4 is our distance there, 2 and 2, plus looking at our 90, remember it's spinning about D, so it's spinning that way, again anti-clockwise, so negative 90 times, now perpendicular distance is 1. So even if we extended that there, that's our perpendicular distance down to there. 1 meter. And then our RL spinning clockwise, so it's a positive RL times 246 equals 0. So we've got negative 240 minus 90 plus 6RL equals 0. RL is equal to 55 kilonewtons, positive, and that would mean that's going up there. So there's a reaction RL. Now using the sum of the vertical forces, we could find the reaction at the right for the vertical RRY. So I'm going to say anything moving up is positive, sum of the forces vertical is equal to 0. So 60 is coming down and the RL that we found is going up, so they're opposing each other. So we've got RL is worth 55 minus 60 plus RRY, the unknown, is equal to 0. So RRY is equal to 5 kilonewtons. Positive value, which means it stays the way it started, going up. Some of our horizontal forces, I'm going to do something different this time just to show you it doesn't matter which way you select it. So if I say I'm going to go to the left, is going to be positive. Sum of the forces horizontal is equal to 0. We can say we've got 90 is our only horizontal force, and our unknown is Rx. So we've got 90 plus RRX is equal to 0. So RRX is equal to negative 90. Now, getting a negative answer means that our arrowhead has to be reversed. So I can write that RRX is equal to 90, and I reverse my arrow by saying it's going that way. So now we've got our horizontal and vertical components of our unknown resultant RR. We can simply find that hypotenuse by a squared plus b squared equals c squared. So we can say RR, and I'll draw a little triangle over here so we can get a picture of what we're doing. If we've got 5 kilonewtons going up, $90 going to the right, and we know our resultant arrowhead goes in the opposite direction, and that is R. So the square root of 90 squared plus 5 squared is equal to 90.14 kilonewtons. So that's our value RR there. Got a 90-degree triangle. So now I can pick either angle to find. I'll call that one there theta. And I've drawn my resultant in, so now I just need to find theta. And we know from previous examples theta is equal to inverse tan times opposite over adjacent is equal to 3 degrees. And if I was doing that in an exam, I've clearly illustrated that I've got RR going up at an angle. I've shown the angle that it's going. I've shown the sense. It's got its point of application way back here, and its magnitude has been given as RR 90.14. So all the information is there on my page. Page 55, complete.